Okay, so this is going to be the de novo synthesis portion, and then I'll do salvage and catabolism. So we know that from the HMP shunt, ribose 5-phosphate or whatever it's called, the sugar, it comes from it. And so here we use PRPP synthetase. And just a forewarning, this info, some of it is irrelevant to the class, just a little bit of it. It's from my USMLE textbook, so that's why. So PRPP synthetase and ATP, they create PRPP, which is what we need to know. The synthetase is what we don't need to know. And then it goes through, so it can either go to pyrimidines or to purines. We're going to talk about purines first. So from PRPP, it has PRA, which is the commitment step. From that point, it can't turn around anymore. And it adds all these carbons and nitrogen. So it has glutamine, glycine, folate, carbon dioxide, and aspartate. And that's what creates the IMP. So all those things make up the IMP molecule. So we're gonna just chat about it real quick. So this is PRPP, the black right here. This purple right here is added by glutamine. It happens twice, but all we need to know is that it's added from it. The middle of it, and kind of this portion, is glycine. And then the green here is folate. Then we have aspartate here, and then carbon dioxide as orange. And this says here that IMP is regulated. It needs AMP. If it needs AMP, so this is just a little after the IMP note. If it needs AMP, it will use GTP to make AMP. And if it needs GMP, it will use ATP to make GMP. It's just how it kind of works out. This is all done in the cytosol, and it's expensive. It costs 6 ATP to synthesize 1 IMP. Okay, so that's all you really need to know about purine de novo synthesis. Pretty straightforward. Oh, and excuse me, there's this little mnemonic here. It's pure as gold, so purines, and we have A and G, or adenine and guanine. Okay, on the other side we have cut the pie. So pure as gold and cut the pie. Cut the pie would be for pyrimidines. So that's how you would know which is what. So normally we'd just start at the PRPP for purines, but now we got to start earlier for the pyrimidine. So before it makes the sugar, it has glutamine and carbon dioxide and ATP, and through a few reactions, it makes carbamyl phosphate. And then from carbamyl phosphate, it adds aspartate to it. And this is the commitment step. From here, we are going to continue to UMP. So orotic acid, and then we add in PRPP. I think we also add in ATP, and we create UMP. And this little portion isn't important. It's not really relevant, other than this is how you make the deoxy DNA portion. But from UMP, we can make UDP, and then from UDP, we can make UTP, and it has to be triphosphated to be able to make CTP. But anyways, now that we have UMP, let's talk about the structure. So we still have that PRPP. Here's that aspartate, that one rate limiting step or commitment step here. We have glutamine here, and then we have, I didn't even write it down. Carbon dioxide is this orange part. So some notes about the pyrimidine side is the first step is in the cytosol, and the rest of it is in the mitochondria. It requires a lot of energy, again, It's regulated at the carbonyl phosphate, but it's not the commitment step. The commitment step is the aspartate transferase. And UMP is required to go to UTP to make CTP. So in the process, UTP cleaves NH2 from glutamine and replaces the C double O bond to form CTP. So if we were to erase this C double O bond and put a C with an NH2 on it, that would create CTP. And that would be, obviously it'd have to be tri. This is mono, so it'd have to be tri. But that's what we have to do, is we just change that to an NH2, and that's how you would make CTP over here. But that's the Novo in a nutshell.